అమ్మతోనే మాట్లాడిన అరగంట సేపు అసలు సమస్య లేదు సరే ఉంటా जरा 10 రోజులు పాడకపో నన్ను మహాజరా కానూని మాకు ఎవరన్నా చేస్తే గట్టిగా అరగంట మాట్లాడితే గ్రేట్ మాట ఏదన్నా చెప్తా ఉంటే ఊవటం ఏదన్నా అంటే తప్ప దగ్గర చేయకూడదు మాట్లాడతాను ఎందుకు బాబాయ్నాడు పెళ్లికి ముందు ఫోన్లో అందరూ గంటలు మాట్లాడతారు కదా నీకు తప్ప ఇంకేం రాదా అని అడిగేవాళ్ళు అసలు గంటలు కనబడి ఫోన్ మాట్లాడతారే నువ్వేంటే కనీసం 10 నిమిషాలు కూడా మాట్లాడు న్యాయంతో అని అడిగేవాళ్ళు మా వాళ్ళు లేకపోతే ఎక్కడో చాటున్నానని పెట్టేసేదాన్ని పొయ్యి దగ్గర ఉన్నాను ఏదో దగ్గర ఉన్నాను ఫోన్ పెట్టేసాను మాట్లాడలేదు కాదు
Good morning, students. So far in last class, we have to discuss that the technologies, what are the technologies you have to use in data mining. And what kinds of patterns you have to use in data mining. These are the concepts we have to discuss in last class. Now, in today's class, we have to discuss with the data mining task primitives. The data mining task means, for example, you have to consider the database. In the database, data into the database in the tables by using can delete the statements. Commit the database by using this structured queries. Mainly, you have to use it to do on the database. But whereas in the whenever we have to discuss with the data mining, here you can use the one query language you have to use, that is the data mining query language. Whereas in the databases you have to use the SQL, but whereas in the data mining you have to use the data mining as DWDM. So here by using the data mining query language, you can perform the various operations on data mining. So what is the data mining task? Tasks are mainly we have to represent to perform a particular operation. That is simply can call it as the task, data mining task. Data mining task can be specified in the form of data mining query, which is the inputs defined in terms of data mining. So user to interactively communicate with the data mining system during discovery in order to direct the mining process. So these are the data mining task primitives. So whenever you want to perform the operations, you have to use in data mining task primitives. First one, these are the generally you have to represent in the data mining task primitives. First one is the set of task relevant data. So how we can mine this data, and it specifies the portion of the database or a set of data in which user is interested. Simply, you can represent it as a set of task related data can be mined in data mining task primitives. And the second type of primitive is task of the knowledge to be mined. First case is the task related data you can mine. Second case is the kind of knowledge. So whatever the keyword you have to type it on Google form. So just you have to type the keyword, that appropriate information you have displayed on the screen. That keyword related knowledge information to be mined. And the third one is the background knowledge. For example, you have to type the keyword. The keyword related type about you can write on a keyword you have to type a particular algorithm like FCFS algorithm, first come first serve algorithm. So in FS algorithm, whenever you have to type, automatically it displays the background information, who implemented that all information you have to display on the screen. That is the simply you can represent it as background knowledge to be used to discover the discovery process. And the next one is the interestingness measures and thresholds for the pattern evaluation. Interestingness measures and thresholds for the pattern evaluation. Mainly, you have to represent it here. Whenever the particular keyword you have to type, so simply you can use they may be used to guide the mining process or after discovery to evaluate the discovered patterns. Different kinds of knowledge may have different interestingness measures. The next one is the expected representation of the visualization, that is the discovered patterns. This refers to the form of in which discovered patterns are to be displayed, which may include the rules and tables, charts, graphs, decision trees, and cubes. That is simply you can calculate that representation for the visualization. Data mining query language. So here by using this is the various types of data mining primitives. So based on the task related data, based kind of knowledge, and based on background knowledge and interestingness of measures and thresholds, and expected representation of the visualization. So these are based on this basic data mining primitives. Based on these primitives only, you have to display the result. So how we can display the result? By using the query languages we have to use to modify or you can display the screen. So data mining query language data mining query language can be designed to incorporate these primitives, uh, allowing users to flexibly interact with the data mining systems. Simply you can represent it as this is a data mining query language that is simply you can use. Whereas in the databases you have to use the SQL structured query language you have to use, but whereas in data mining you have to use the language that is the DMQL, data mining query language. So here you have to see this diagram which shows how it process for the primitives of the specifying the task, specifying data mining task. And the first one is the task relevant data. In the first relevant data, you have to display like titles, database, warehouse cubes, conditions for the data selection, and relevant attributes for relevant attributes or dimensions data grouping criteria. So this is a task related data. Whatever the keyword you have to type it on Google search, that related information you have to display on screen. And the next one is the knowledge type to be mined in a characterization. Knowledge to be mined in the characterization, mainly we have to present that keyword related knowledge you have to display on screen by using methods, characterization method, discrimination method, and association methods, and a classification and prediction. This is the knowledge creation and discrimination, association, classification, and clustering. These are the methods we have to represent knowledge to be mined. And the next one is background knowledge. In the background knowledge, that is simply can represent it as concept hierarchies, use beliefs about the relationship in the data. Background knowledge means that complete information about that particular concept. That is the background knowledge, like concept hierarchies. We can discuss it here. That is the user beliefs about the relationship in the data. And the next one is the pattern interestingness measures. That is simplicity, certainty, and utility and novelty. So here the pattern in interestingness. So based on that selfly we have to more care on a particular concept. That is simply call it as pattern interestingness measures. Simplicity and certainty and utility and novelty. That is simply you can call it as pattern in interestingness. And then last concept is the fifth one is the another primitive. Primitive is the visualization of discovered patterns. That is the rules and tables and reports, charts you have to graphs, decision trees and cubes. That is the drill down, roll up, related data you have to display on screen. That is the visualization of discovered patterns. These are the primitives of this specifying a data mining task. These facilities of a data mining system is communication with other information systems and its integration with the overall information processing environment. Series diagram shows concept hierarchy of the attribute dimension is the root node represents the most general abstraction level and denoted as all. So here in this diagram it shows the concept hierarchy. In the concept hierarchy, that is the all you have to represent it. That is the age and middle-aged, youth and middle-aged and senior. So what is their ages? The youth 20 to 39 you have to represent it as youth, and middle-aged you have to represent at 40 to 59, and senior you have to represent 60 to 89. So these are the people you have to represent it as youth, middle-aged, and senior people based on that concept hierarchy. Clear? There are several proposals. There are several proposals on data mining languages and the standards. So here you can use the data mining query language. In the data mining query language, which is designed for a teaching tool based on the primitives. It was used to specify the data mining queries appear through this. Mining classification rules. Suppose a marketing manager of all electronics would like to classify the customers based on their buying patterns. We are especially interested in those customers whose salary is no less than the 40,000, whose have the bought more than 1,000 worth of items. So that is you have to represent it as many mining classification rules. For example, here you have to see the DM by using the DMQL language, data mining query language. By using this DMQL, you can define like this: use database. So the particular database we have to use database. That is the name you have to given first one, then hierarchy, then a hierarchy you have to given for that database. What are the tables you have in each table? What are the attributes are there? With all attributes you have to represent it here. From the user hierarchy location hierarchy, from the T dot branch and age hierarchy for the C dot age. So here you have to represent it as two tables. That is the T and C T and C. So from that tables you have to represent the hierarchy, and mine classification as a promising customer. Uh, so classification means like promise you have to represent it to the people mine call classification as a promising customer in relevance to the C dot age, C dot income, I dot type, I dot place made, dot made, and T branch from customer C and item I transaction. So here you have to take consider the three tables, that is the customer table, item table, and transaction. From these three tables, you have to represent the relevance. So here you can specify the condition with the group class where the I dot item ID is equal to T dot item ID, and the cost dot T dot customer ID is equal to T dot customer ID. Both are equal. And then if the C dot income is greater than 40,000 and I dot price is greater than 100 rupees. So this is the way you can represent the data mining query language group by T dot customer ID. Having the sum of the I space is greater than 1,000, which the data mining query is parsed to form a SQL query that retrieves the set of task relevant data specified by lines 1 to 4. Line 1 is represents the database. Line 4 represents the relevant to the attributes. So this is regarding to this uh, task primitives, that is the data mining primitives. So explain about in the external point of view, they will be asked like this: explain about the or discuss about the data mining primitives. So you can write all these 5 primitives: task relevant data. So this is the task relevant data you have to represent. That is the task relevant data. Knowledge to be mined, background knowledge, pattern interestingness, and visualization. So these are the 5 points. So you have to represent it as data mining. And the next one is integration of the data mining system with the database and or data warehouse system. How you can integrate the database and data warehouse? How we can integrate with the data mining and database or data warehouse? So, for example, first the entire data, whatever the data you have, that is data in and we have to store into the databases. From those databases, we have to arrange it in consistent data in data warehouse. From that data warehouse, you have to apply the data mining algorithms. Whenever you have to using the data mining algorithm to that data warehouse, it retrieves the you have to display the how that is the process of the data warehousing and data mining. So here how here you have in this concept you have to explain how you have to integrate with the data mining system with database and data warehouse. So here you can see this diagram shows So here you have to how you can integrate a good system architecture with a system to make a best use of the software environment, accomplish the data mining task in an efficient and timely manner, interoperate and exchange information with the information systems. See here, this is the themes of the coupling. So here you have to see a data warehouse. If a data warehouse in a data mining system was a standalone system, or there is no database or data warehouse system with which it has to communicate the simple scheme is called as no coupling. So here we can represent this. Next one is the tight coupling. Tight coupling means that a data mining system is smoothly into the database and data warehouse system. This is regarding to this integration with the data mining systems with the database or data warehouse. Next one is which technologies you have to use. Already you have to discuss in last class. Already you have to discuss in last class. Now, in today class, another concept you have to discuss with that. Which kinds of applications to be targeted. So here you can target the different types of application. Like whenever you are using the business oriented, that time you have to combine in data warehouse. That time you have to use the concept business intelligence. Business intelligence by using the BA method. It is a technologies to provide the historical and current predictive views of the business operation. Example include the reporting online reporting online, analytical processing, business performance intelligence, and benchmark. Uh, Benchmarking and predictive analysis. So this is the process where we can represent the business intelligence. These are the kinds of application to be targeted. First one is the business intelligence. In the business intelligence, technologies mainly provide the historical and current productive views. Here, data mining is the uh, core of business intelligence. Online analytical processing tool is a business intelligence rely on data warehousing and data multidimensional data mining. Classification and predictive analysis techniques are the core of the predictive analysts in data in business intelligence, for which there is many applications and analyzing markets. So this is regarding the business intelligence, and the next one is another application is the web search engines. Web search engines mainly have to represent what type of searches. Here you can web search engine is a specialized computer server and that searches the for information on the web. This search results the user query often return to the list of the file that is simply called as hits, and the search results of user query and often return in a list is called hits. The hits may consist of web pages and images and other types of files. Some searches engines also search and return data available in different public databases or often directories. That is simply you can call it as web directories. That is the web search engines. Web search engines mainly you have to represent it as first one is a handle the huge and even growing amount of data you can search. Whenever you cannot be processed, use it one or few machines instead of such engines are often to be as a computer cloud. So with the computer cloud only, you can easily you can search that particular keyword. Next one is the second. In the second, mainly you have to web search explains the often have to deal with the online data. And the third one is you can represent the web search engines often have to deal with the queries and asked only a few small number system number times. This is regarding to this website engine, and mainly here we can use the two types of applications we have to use in data mining, that is business intelligence and web search engines. Next one is the major issues in data mining. So here we have the number of issues in data mining. First one is the data mining is a dynamic and fast expanding field with great strength. So partition them into 5 groups: mining methodology, user interaction, efficiency, and scalability, and diversity of data types and data. Mining methodology. Researchers have been rigorously developing and data ranking methodologies that involves involves the investing of different data mining methodology. Major issues in the data mining. First one is the mining methodology. So what type of methodologies you have to use in mining methodology? First one is the mining various and new kinds of knowledge, mining knowledge in dimensional space, data mining, interdisciplinary effect, boosting the power of discovery in a networked environment, handling uncertainty, noise, and incompleteness of data, pattern evaluation, and pattern. So this is the simply you can represent that these are all comes under the mining methodology. And the second one is another issue is user interaction. User interaction is simply can represented as interactive mining and incorporation of background knowledge and I hope data mining and data mining query language, presentation and visualization of data mining results, efficiency and scalability of data mining algorithm, parallel and distributed data intensive mining algorithm. You have to parallelly distributed and incremental mining algorithm. And the last one is diversity of data types. Diversity of database types, data mining and society. First one is the diversity and database types. Generally, you have to represent it as handling the complex types of data. And the second one is the mining dynamic and networked and global data repositories, data mining and society. So here you can represent the social impacts of data mining. And next one is the privacy preserving data mining and data mining with the help scientific discovery, business management, and economic ac- economy, recovery, and safety. So last one is the invisible data mine. So these are the mining techniques we have to use in various cases. So that is the major issues while you have to performing the data mining on various databases or in data warehouse. Okay, these are the major issues in data mining. So next one is some issues related to the database types. That is simply you can say that handling the relational and complex types of data and mining the information for the heterogeneous databases and global information. This is the end of the first unit. This is the end of the first unit. So in this unit, mainly we have to concentrate on data mining concepts. So necessity is the mother of invention with the maintaining the growth of data in every application. Data mining means the effective and scalable and flexible data analysis in our society. So data mining can be considered as natural evolution of information technology and the confluences of the several related disciplines and applications of application domains. So here, whenever you have to apply the data mining, first you have to collect the heterogeneous databases and you have to arrange it into the data warehouse. Then only easily data warehouse. So what is the data mining? Data mining is the process of discovering interesting patterns from the massive amounts of data. As a knowledge discovery process, it typically involves data collection and data transformation and pattern discovery, pattern evaluation, knowledge presentation. So these are the knowledge discovery processes. These are the knowledge discovery processes. For example, we present a multi-dimensional view. For example, you have to use the data mining and data warehouse you have to implement it. That you have to store in the form of data multi-dimensional. Multi-dimensional cubes view is the data mining. The major dimension not the major dimension as data, knowledge, technologies, and application. This is of the data mining. So data mining can be conducted on any kind of data as long as the data are meaningful for the target application, such as database data and data warehouse data, transactional data, advanced database data types. Advanced data types include the time-related sequence data, data streams, spatial and spatio-temporal data, text and multimedia data, graph and network data, and web data. A data warehouse is a repository for a long-term storage of data from multiple sources organized so as to facilitate management decision making. The data are stored under the uh, unified schema, typically summarized the data warehouse system, provide the multidimensional data analysis capabilities, collectively referred to as an online analytical process. Generally, you all are aware that you want to process a particular operation in bank database. So that time in bank databases, whenever you have to apply, that is OLTP you have to use online transaction processing. Generally, you have to use to process a particular operation of the in banks. In banking sectors, you have to use that OLTP one. But whenever you have to use the data mining, that time you have to use the OLAP. You have to use the OLAP. That is the we can call it as uh, online analytical processing. So by using online analytical processing, you have to analyze the data. So here you have to analyze the data and what are the functionalities, what are the issues. So these all things you have to represent it here. Next class will continue the data pre-processing and DMQL, data warehousing, and that is the DMQL, that is the data mining query language statements. What are the statements? What are the queries you have to use it in data mining? These all things we have to discuss in next class. Okay. So today class we have to complete the data mining primitives and as well as what are the issues of the data mining. Okay, clear? This is the end of the first unit. We will continue in next class. That is the second. That is the data pre-processing. Before discussing about the data pre-processing, we can discuss with the DMQL statements. That is the data mining query language statements. Okay, thank you. I will take the attendance. Please wait 5 minutes.
హాయ్ హలో అండ్ నమస్తే అందరూ వెళ్ళిపోవచ్చు ఇంకా. టైమ్ ఈజ్ అప్, అందరు లీవ్ అయిపోండి.
ఫస్ట్ నువ్వు వెళ్ళరా కర్రాడు అరే.
ఎందుకు వెళ్ళిపోతా